Hello and welcome to our video presentations for Mathematic 183 from UiTM Terengganu, Cawangan, Cendering. So basically this is the presentation video with the title of Applications of Differentiations, and our groups consists of 4 members, which is Azli bin Johari, me myself, Muhammad Fitri Rafidin bin Hisham, Muhammad Nazran Hussain bin Zakaria, and lastly Muhammad Ashraf bin Nazri. This video is prepared for Madam Sarah binti Yusof. Our code is CS110 and currently we are in semester 2. So the introductions. First of all, max and min are one of many the problems in the calculus. So moreover, various applications problems in calculus include function for which you want to find max or min value. Domain is determined by the limits that define or imply for a functions. Furthermore, with the domains together, the function will indicate in which methodology is acceptable to use in deciding the extreme value theorem, first derivative test or second derivative test for a max and min value. Moving on to what is max and min. So max and min in mathematical analysis, the maxima and minima, also known as maximum and minimum, which is singular for it, of a function known as extrema, also known as extremum, which is plural, which is the largest and smallest value of a function, either within a given range or on the entire domain itself. So first mathematicians, one of the first mathematicians, which is Pierre de Fermat, he proposed a general technique which is known as inequality for finding the maxima and minima of a function. So next is applications of max and min. What do we use max and min in real life? So one is we use max and min in business, such as small and big business, by trying to maximize the profit or minimize the losses that was done by the company by estimating prices for items. And also the company use max and min to determine how many to keep in stock, such as max or min rate constraints. Next is initial velocity and launch angle. Max and min is used in physics, such as that was shown here, by estimating the initial velocity and launch angle of a projectile to maximize the height or range. So this application is usually we saw in rockets launch project, and also bullets travel from the guns. So lastly, we use max and min in aircraft. How do we use in aircraft is in aircraft ship they use max to calculate the takeoff for an airplane, to determine the maximum to take off, and for the minimum they use for landing, which they calculate the minimum of landing to land in the ship carrier. Okay, so that's all from me. Thank you very much. I will pass to my next member, friend, Azli, to proceed with the next sections of the video.
Okay, hi, my name is Azli. So for the problem segment of our video, a custom rectangular aquarium fish tank open at the top is requested by a customer. The length of its base is 3 times its weight, and the material used on its base is 6 ringgit per square meter, and its sides cost 2 ringgit per square meter. the aquarium tank have a volume of 100 cubic feet, so the customer asks us what's the minimum cost for constructing the aquarium tank and its minimum size. So first things first, we need to find the equation for the minimum cost. Next up, we have to find the dimension that will give us the minimum size of the tank or the aquarium tank. And third and finally, we have to find the minimum cost for constructing the aquarium fish tank.
Hi, my name is Nazran. As you can see here, this is the picture of aquarium. There are two sides of rectangle and is given width and length which is S and H. The area of these two sides of rectangle is 2SH. Next, there are two front side rectangle and is given width and length which is 3S and H. The area of these two front side rectangle is 6SH. And last, the base rectangle. The width and length is 3S and S. The area of it is 3S squared. For question 1, the volume given for aquarium is 100 cubic feet. So using rectangle volume formula, which is 3S times S times H equal to 100 cubic feet, and then simplify it and you can get H equal to 100 per 3x square. Next, you can find the equation for minimum cost. To find it, you have to add three things, which is base plus side and plus front side. You can see here 6 times 3x square plus 2 times 2sh plus 2 times 6sh and equal with 18x square plus 4sh plus 12sh, and then you can simplify it become 18x square plus 16sh, and then you substitute 100 per 3x square into h, and then simplify it to become 18x square plus 1600 per 3x.
Okay, now once we have the equation for the minimum cost, okay, now from there, to find the minimum dimension of the rectangular aquarium tank, we have to differentiate 18x squared plus 1600 over 3x, and we will have this value over here, which is 36x minus 1600 over 3x squared. Then we can let dc over dx, which is the differentiated value, and set it to 0 so that we can find the value of x, and we can simplify and transfer the value into the other side, and we will have x equal to 2.4, which is the minimized dimension or the minimized width of the rectangular aquarium fish tank. And from there we can find the dimension of the length by substituting x into multiplying it by 3, and we will have 7.2, which is the minimized length of the aquarium fish tank. And finally you can find the height by substituting x into the equation for getting h, and you will have 5.8 as the minimized height of the aquarium fish tank. Okay, from here, once we have x, we can test x by using the second derivative test to test whether x really gives us the minimum value or the minimum dimension of the rectangular aquarium fish tank. So from here we have to differentiate again 36x minus 1600 over 3x squared, and we will have 36 plus 3200 over 3x cubed, and then we can substitute x into this expression and we will have 113.2, which is over 0. So when x is equal to 2.4, the second derivative will give us a positive value, which will confirm our calculation that this will give us a minimum value for x.
Hi, my name is Mama Ashraf. Now we want to solve the next question, which is we must find the minimum cost of constructing the aquarium tank. To solve this question, we need to use the minimum cost equation that has been we get in the question 1, which is 18x power of 2 plus 1600 per 3x. From this equation, we need to substitute 2.4 that has been we get in question 2 into x. After that, the calculation that we need to do is 18 times 2.4 power of 2 plus 1600 per 3 times 2.4. After that, the minimum cost that we get is 325 ringgit 90 cents. From all of the calculation, we can summarize that the minimized cost for constructing the aquarium tank is 325 ringgit 90 cents with the dimension that 2.4 meters for the aquarium width, 7.2 meters for the aquarium length, and 5.8 meters for aquarium height. In conclusion, differentiation can be applied to solve our problem in daily life. Example problem that suitable to use the differentiation solution, such as the calculation in define the minimum cost to build the aquarium tank in construction phase, calculation the initial velocity and launch the angle in physics department, calculation to define the minimum and maximum business profit in the trade terminology, and other related problem. Okay, that's all the presentation from us. Thank you for watching.